Howdy! Today's discussion is about the different ways we study the brain to figure out what functions the neural pathways you've been learning about actually accomplish. So far, you know the basic structure and function of neurons, and you know that they use chemicals and electrical charges to communicate. So now we need to talk about what it is they're communicating and where the pathways for related functions tend to be located in the brain. This is going to help you understand more about scientific methods of studying the brain, ethical implications for studying brain function, and a foundation of knowledge to help you become more effective at evaluating and interpreting research and popular media reports about the science of psychology. We're going to start with the oldest method humans have for understanding what the parts of the brain do: lesion deficit studies. We've actually already seen this one when we talked about Phineas Gage, the man who had dramatic frontal lobe damage followed by dramatic personality change. Lesion deficit means the loss of function, the deficit, that follows damage to the brain that results in an area of dead brain tissue, the lesion. As with Phineas Gage, we can study people who've sustained brain damage somehow and collect data on the kinds of things they can and can't still do. Now, of course, what we can't do is manipulate the brain damage to see what kind of deficit that might produce. That would be entirely unethical. So, what kinds of studies must lesion deficit studies be? Hopefully, you've figured out these can only be observational, and therefore what kinds of data and conclusions can we draw? Right again. These can only produce observational data, and we can only use them to find patterns that help us generate hypotheses. Ethically, of course, we can't experimentally test those hypotheses with humans. Again, we can't create brain damage in a person to see what happens. We can do animal studies with other mammals, but fortunately science and technology have also advanced enough that we have some other ways of figuring out what the parts of the brain do. One of these methods is called deep lesioning, in which electricity is used to destroy or lesion an area of the brain. Now you may be wondering how on earth this could be ethical. Usually, in cases of severe epilepsy, in which the patient's seizures can't be controlled by medication, surgeons have to go in and destroy the part of the brain where the seizures originate. In these cases, we can test the patient before and after surgery to see what functions the lesion destroyed, and from that we can infer what the destroyed part of the brain used to do. Similarly, with ESB, a milder, non-damaging current can be used to stimulate, not destroy, the part of the brain targeted for surgery. The surgeon touches the cortex with the electric probe to cause a neural impulse to be generated in a certain spot on the brain. As you know, part of neural transmission is electrical. Turns out that, just as with externally introduced chemicals, the brain doesn't know the difference between electricity it generates versus electricity that's externally introduced. So, when the probe causes a neural impulse, it triggers the pathway connected to the point on the cortex that was stimulated, and the patient, who's actually awake during this procedure, can report what they experience: a memory, a sound, a smell, a muscle contraction, and then the patient can make a more informed decision about whether they want to move forward with deep lesioning to treat the epilepsy. That is, they'll have a better idea of the deficit they will experience after the surgery. These kinds of data give us a lot more information about brain function, but they're still just single case studies, so they're still observational, and we still can't generalize to the healthy brain. Now, before we move on, I want to give you more information about lesion deficit in two particular areas that you're much more likely to encounter in real life: Broca's and Wernicke's areas, damage to which is associated with aphasia, a loss of language function. There are two common sites of damage after stroke, Broca's and Wernicke's, and stroke is becoming increasingly common in our society. Now, it's true that stroke can cause damage in other areas. I know some of you have already had loved ones who've suffered stroke, and in many of those cases you'll have noticed the person had a language problem after. The first kind of problem I'll tell you about is associated with damage to the place called Broca's area in the left frontal lobe. This area is typically linked to the ability to produce speech, that is, talking. That's called Broca's aphasia. It's important to understand that the person has a very hard time getting words out. But unless there's also other damage elsewhere, they can usually understand what you're saying to them and they know what they want to say. They just have a hard time physically producing the words. Pause this presentation for a second and click the link to hear what it sounds like when one Broca's aphasic tries to talk. She's actually very darn good compared to the Broca's aphasics I've worked with. I suspect part of that is because she was so young when she had her stroke, so her brain was more plastic than the typical older stroke survivor. Remember brain plasticity. Be aware too that Broca's aphasics typically don't have much trouble with reading and writing. With Broca's aphasia, the problem is speech production. Wernicke's aphasia, on the other hand, is a disruption in the ability to understand language and to produce meaningful speech. They don't have a problem producing word sounds, but the sounds that come out aren't meaningful. Sometimes it's called word salad. Typically, Wernicke's aphasics also have trouble understanding and producing meaningful written language, unlike Broca's aphasics. Alright, now let's talk about some much more modern ways of looking at what the parts of a healthy brain do. There are numerous different specific methods, so I'm just going to explain to you the three basic categories that they fall into. Understanding the kinds of information each category yields will tell you a lot about what the individual methods can investigate without you needing to know all the details of each method in the category. Throughout this course and in real life, you'll hear lots of research outcomes based on these methods, so it'll make you a better consumer of information to know a little bit about what exactly is being measured. The first category of methods measures electrical activity in the brain. You already know that neural communication is in part electrical, so this makes sense. These kinds of studies are especially good for measuring how long it takes for the brain to engage and respond to some particular task. So these kinds of studies usually measure the speed of brain function. That should make some sense given what you already know about the axon and the electrical part of neural communication. The next category for studying the brain looks more particularly at where in the brain activity is happening during some specific task. Hemodynamic methods measure where blood, and therefore oxygen, is being sent and used. From that blood movement, we can infer the part or parts of the brain involved in accomplishing the task. Finally, structural brain imaging studies look at the shapes and sizes of brain structures. These are static images that tell us whether a brain structure is formed normally, and they can also detect whether there's an abnormal or atypical area such as a lesion or a tumor. These kinds of studies don't tell us about brain function or brain speed, just about structure. To wrap up, remember that all these ways of studying the brain give us information about how to understand the different kinds of data we can collect about the brain and the kinds of questions we can ask and answer using the different methods. As we saw with different theoretical perspectives on studying psychology, putting together information from several different methods of studying the brain will tend to give us the most complete answers. And this again is the general lesson of critical thinking, to understand your sources and seek multiple perspectives on the question at hand. Thanks and gig 'em.